Now we have what's called the energy impartition or imparted energy. What's the definition of imparted energy or energy impartition? أكيد نحن عم نحكي in the context of radiation or particle interactions with matter. هيدا الشيء اللي نحن عم نحكيه ونركز عليه بالتحديد. Interaction of particles with matter. So energy impartition, it refers to the transfer of energy from the radiation or particle to the atoms or molecules in the material it encounters. So the transfer of energy. هلا term energy imparted refers to a small volume. أكيد كمان الموضوع مرتبط بالenergy deposit with high energy radiation or particles interact. When these high energy radiations or particles interact with matter, they can transfer some or all of their energy to the atoms or electrons in the material. This energy transfer can lead to various physical effects and to various processes, of course, depending on the type of radiation or particles involved. فإذا لما بيصير في interaction بين الراديشن والماتر حيصير في عندي energy deposit through a series of individual events or interactions. Each event adds a small amount of energy to the matter. هلا the energy imparted يلي حعبر عنها بإبسلون responds to the radiation by producing a signal. This signal correlates directly with the energy imparted within the detector's volume. So هيدا signal is a measure of the total energy transferred to the detector by the incoming radiation. يعني الانرجي imparted بتساعد أو هي used to quantify the total energy delivered by radiation to a specific volume of matter. And this is essential to understand and to measure radiation interactions in the field of medical imaging and in the field of radiation protection and physics research. هيدا الانرجي imparted فإذا عبرنا عنها بإبسلون. The energy imparted to matter, to the tissues, for example, in a given volume, in a small volume, هي sum of all energy deposits, sum over I, of all energy deposits within the volume, in the volume. يعني بمعنى تاني هي sum of energy imparted in all those basic interaction processes. In all the interaction processes في عندي energy imparted. The sum of these energy imparted هن الانرجي هن الابسلون يلي حكي عنهم بهيدي الايكويشن. فإذا summation is performed over all energy deposits in that volume, in that specific volume. For example, a radiation detector responds to irradiation with a signal, let's call this signal M, which is basically related to the energy imparted in the detector volume. Stochastic of energy absorption. هلا energy absorption process in matter هي فيني اعتبرها stochastic or random process or stochastic process لأن الانرجي deposit occurs in a probabilistic way. The total energy imparted is also a random quantity, a stochastic quantity that follows a probability distribution. أكيد بس نحكي عن randomness أو stochasticity بنحكي ب probability. So we don't have a fixed value, we have a probability distribution, a specific probability. So the energy imparted is always statistically distributed during the time interval considered. هلا ليه stochastic؟ لأن لسببين. أول شيء لأن the distribution comes from two sources. في عندي fluctuation in the number of events and fluctuations in the size of events. So بالنسبة لأول point fluctuations in the number of events, here the number of interactions يلي هن number of events. أكيد where the radiation deposits energy. The number of interactions within a specific volume can vary. And this lead to different amounts of energy being imparted. Fluctuations in the size of events, here each interaction event can deposit a different amount of energy. So this will contribute also to the variability in the total energy imparted. The determination of the variance of energy absorption must take into account these two sources. We have to take into account these stochastic factors, these two sources. So to quantify the uncertainty and to quantify the variability in energy absorption, it is necessary to determine the variance of the energy imparted. هيدي the variance calculation لازم تاخد بعين الاعتبار the fluctuations in the number of events and the fluctuations in the size of events. فإذا لأن عندي stochastic factors, the energy imparted in a volume is not consistent. It varies. It varies in a way that can be described by a probabilistic approach, by a probabilistic distribution. So هيدي the probabilistic approach or probabilistic distribution reflects the random nature of radiation interaction. We have randomness. Radiation interaction ما بتكون ثابتة. Interaction ما بتكون ثابتة. بيكون في عندي fluctuations، بيكون في عندي randomness، بيكون في عندي تغير. هيدا التغير أو الراندومنس أو الستوكاستيسيتي لازم ناخدها بعين الاعتبار. In radiation physics في عندي two important concepts. So نحكي عن energy absorption و energy transfer. فإذا هدول التو terms energy absorption و energy transfer بيعبروا عن الانرجي. كيف الانرجي بتعمل interaction مع الماتر. How the energy interacts. How energy from radiations interact with matter. Energy absorption, this term applies to charged particles such as electrons and protons. بينما energy transfer, the term energy transfer applies to uncharged particles يلي هن مثلا photons و neutrons. So بالنسبة للcharged particles مثل الالكترونز والprotons, when these particles pass through matter, they directly interact with the material, transferring their energy to it. مباشرة بس يلتقوا هدول البارتيكلز، بس يعملوا interaction مع الماتيريال، حينقلوا الانرجي اللي عندهم للماتيريال. These interactions happen through electromagnetic forces where the charged particles lose energy to the surrounding atoms and molecules. And this will lead to ionization and excitation within the material. هيدا الشيء اللي بيؤدي للionization بقلب البادي أو يعمل excitation بالماتيريال. بالنسبة للإنرجي ترانسفير، فإذا بنحكي ب uncharged particles مثل النيوترونز، مثل الفوتونز يلي هن light particles. هدول particles uncharged يعني they do not carry an electric charge. They interact differently with matter. Instead of direct energy absorption, the uncharged particles transfer their energy through secondary processes. فإذا بنحكي هون عن secondary process. مثلا, a photon can transfer energy to an electron via the photoelectric effect or via Compton scattering, and thus creating secondary charged particles. These secondary particles then deposit the energy in the material. فإذا ما في عندي direct deposit للإنرجي، ما في عندي direct process، في عندي deposit للإنرجي بس بsecondary second step or secondary particles. السكندري بارتيكلز هن بيعملوا ديبوزيت للانرجي بالماتيريال. السكندري بارتيكلز بس نحكي عن سكندري اكيد بنحكي مثلا كثير مهم انه نذكر الفوتو الكتريك ايفكت والكومبتون سكاترينج مثلا. photoelectric effect والكومبتون scattering create secondary charged particles. So the energy transfer described how the uncharged particles initiate interactions that result in energy being deposited in the medium through secondary charged particles, بينما energy absorption refers to the energy deposited by the charged particles بحد ذاتهم as they directly interact with and lose energy to the medium, to the material, to the tissue. Loss of energy experienced by the incident electron. We have an incident electron. أكيد في interaction مع الاتوم مع الماتيريال. هيصير في عنا loss of energy. هيدي loss of energy is at the same time absorbed by the absorber atom and thus by the medium. فإذا بنصير نحكي ما بنحكي بس ب energy loss، ولكن كمان بنحكي ب energy absorption when the atom absorbs this quantity of energy. We have a third term concerning the energy. فينا نحكي عن energy transfer. So هيدا اللي حكيت عنه هون مبدئيا. So عندي energy absorption وعندي energy transfer. So energy transfer is the energy that is transferred in a photon interaction to a light charged particle. أكيد هيدي light charged particle هيدي يعني نحكي هون ب secondary electrons for example. This is called an energy transfer. So the energy that is transferred in a photon interaction to a light charged particle. الانتراكشن بين فوتون ومثلا secondary electrons. This is called an energy transfer. هلا فيني اعبر عن الانرجي ترانسفير. برجع بذكر انه الانشارجد particles يلي هن الفوتونز والنيوترون. So after an interaction with an atom الفوتونز might disappear. هلا شو ممكن يصير يعني هلا بعد الانتراكشن اذا الفوتون عملت انتراكشن مع الاتوم او مع التيشوز الفوتون might disappear. يعني هون بنحكي ب complete absorption وجزء من الانرجي is transferred to light charged particles. بينما في عندي بروسيس تاني ممكن تصير يلي هي الفوتون scattering. so الفوتون might scatter. فينا نحكي عن scattering of photon. الفوتون might scatter يعني might deviate, might change its direction. So the resulting photon has بالphoton scattering the resulting photon has the same energy as the incident photon and no light charged particles are released in the interaction. أو the resulting scattered photon ممكن يكون عندها lower energy than the incident photon. يعني ممكن يضل عندها نفس الانرجي ولكن ممكن كمان يكون عندها lower energy and the energy excess is transferred to a light charged particle, to electrons for example. هلا this process, the process of energy transfer can describe or can be described using the energy transfer coefficient. The energy transfer coefficient اللي هو mu TR. It quantifies the average energy transferred from the photon to the kinetic energy of the charged particles produced. So هو mu ETR over H mu. ETR هي average energy transferred from the primary photon. H mu بتعبر عن energy بتعبر عن kinetic energy of charged particles. So energy transfer is the process by which a photon imparts part of its energy to light charged particles, typically second electrons, giving them kinetic energy due or during the interaction. في عندي relationship بين energy transfer والenergy absorption. So for charged particles, most of the energy loss is directly absorbed. فإذا بنحكي هون energy absorption. For uncharged particles, the energy is transferred in a first step to secondary charged particles. وهذا الشيء بسميه أنا energy transfer. فإذا this is like a summary about the main idea. فإذا بصير في عندي energy transfer. In a second step, secondary charged particles lose their energy according to the general behavior of charged particles. كمان بنحكي هون ب energy absorption. So the energy of uncharged particles like photons or neutrons is imparted to matter in a two-stage processes. هيدا بالنسبة للإنرجي.